All that is left then is to answer the final part of the challenge. How many different consecutive totals can we find? In other words, can we find any numbers that would work on the reverse of the pancakes to make these new sets of consecutive totals? Well, to find out, we can approach this question in the same systematic way we used to answer part 1 of this challenge, like this. Starting with our first new set of consecutive totals, we can work out all of the possible missing numbers like this. We know that we still have the numbers 4 and 5 on the front of each pancake and that they make the total 9. Next, we need to consider all of the ways we can make the other totals by substituting one number at a time. So that 4 add 4 equals 8, 3 add 5 equals 8, 4 add 6 equals 10, 5 add 5 equals 10, 4 add 7 equals 11, and 6 add 5 equals 11. This gives us all of the possible numbers for the back of each pancake: 3, 5 or 6, and 4, 6 or 7. Just as before, we need to narrow it down, which we can do by working out which combinations of numbers make the consecutive totals needed, other than 9, because we already know that 4 add 5 equals the 9. And with a little rearranging of the numbers, we can see that 3 add 7 equals 10, 5 add 6 equals 11, and 6 add 4 equals 10, which now gives us the pairs of numbers which will possibly work together. By substituting these numbers into our calculations, we can see which will work as a complete set. Starting with our first pair of numbers, we find that 4 add 5 equals 9, 3 add 7 equals 10, and we also find that 3 add 5 equals 8, and 4 add 7 equals 11. Our first pair of numbers work as a set. Next, let's substitute the 5 and 6 to see if they work. 4 add 5 equals 9, 5 add 6 equals 11, and when we try 5 add 5, it does equal 10. However, when we substitute 6 into the question 4 add what equals 8, we find out that 4 add 6 in fact does not equal 8. So these numbers do not work in the set. Finally, when we test the 6 and the 4 as a pair of possible numbers to see how well they work, we find that 4 add 5 is still 9, 6 add 4 equals 10, 4 add 4 equals 8, and 6 add 5 equals 11, which demonstrates that there are two possible pairs of answers for the numbers on the backs of the pancakes which make the 4 consecutive totals 8, 9, 10 and 11. In the same way, we can find out which sets of numbers work to make our 2 remaining sets of 4 consecutive numbers. Let's fast forward through our workings to find out what works and what doesn't. challenge complete. We have found out that for each of the sets of consecutive numbers, there are 2 possible solutions. Which just leaves me to wonder, if we repeated this challenge, but say with a different pair of numbers on the front of the pancakes, and maybe a different starting set of 4 consecutive numbers, then would there always be 4 sets of consecutive numbers to test, with 2 possible solutions for each? Or do some sets of numbers work differently? And if so, why? What do you think? We'd love to hear your thoughts on this, so why not drop us a line?